I'll write few examples for implicit and explicit casting so that you can write the same to your notebook and practice it. So here I have int I equal to 10 and float f equal to I. So implicit casting is happening here, and I'm printing the value of f. So what will be the output? Output will be 10.0, and we can say the uh, implicit casting happened here where widening conversion has happened. That's what we can say. widening, widening. Now same way, double d equal to let's say 10 point, or we can straight away say f. So again implicit casting is happening here. Now let's go with examples for explicit casting. Explicit casting. So what would happen here? Some examples. Let's say same int num equal to f. This we cannot say. The reason is because f is of type float. We cannot assign it to indirectly. We have to do explicit casting. How do you do that? This destination type will write here. Now let's change the value of f. Value of f is 10. Let's say f equal to, we'll reinitialize with 10.1. See, now one more thing you need to know. This is one of the question they will ask you in the interview. Very important. And they'll tell you write the output. Let's say we'll write sys out here and we say num. Okay, so let me ask you, you tell me what do you think is the output? Suppose if you say output is 10, it is wrong. The reason is because 10.1 is of type what? 10.1 is of type double. Remember floating point literals? 10.1f, either small f or capital F, is of type float. So you will get a compile time error actually. Again saying that possible lossy conversion from double to float. See this? Possible lossy conversion from double to float. Not possible. So what I should do? I should say f. Now the output will be 10. So you can say explicit casting with loss. Now let me give you another example. Explicit casting without loss. There's a byte. We have anything on bytes? No. So byte b equal to byte, I'll say num. What's the value of num? We know that one, it is 10. And after this, if I print the value of b, what do you think is the output? So obviously it is 10, isn't it? See the last one. So here we can say we done explicit casting without loss. Sorry, there is a typo. Loss. I was thinking something is missing, something is odd. Loss. Okay, so we had a second example where we seen explicit casting without loss. Let me write one more example for with loss. Let's say int var. Do you have anything called var? var? No. Good. Int var equal to, let's say what's the range of byte? It is minus 128 to 127, right? So let me assign 128 to this guy. Now byte, okay, we already have byte here b, so I'll say b equal to again byte. So basically more like reinitializing. So byte value was earlier, value was 10. Now we are reinitializing with another value. So that is casting 128. So what do you think is the output now? If I say system dot println b, what do you think is the output? Here you have to understand, obviously 128 cannot fit inside byte, so there will be a loss. Whereas in case of floating point numbers, we are able to clearly make out like point something, this value is lost. But here I leave this as a work to you. You go and check what is the output you see. So we can say explicit casting with loss. Okay. Again we learn casting, that is with respect to character. Okay, this whatever we studied is more than good enough when it comes to casting. But know this one, casting is very important. One important point about the casting, from primitive to primitive of similar types like numeric or so primitive to primitive we can do the casting, and object to object we can user defined data type to user defined data type we can do the casting, that is class and objects in future. Whereas from user defined data type to primitive we cannot do the casting. See you in the next video.